Over the last few lessons, we have had a data set and we found the line of best fit or the curve of best fit, or we called it the regression equation that represents that data set. Today, we're going to look at how well does that equation really represent our data. We're going to be using graphing calculators, so if you don't have one, please pause now and go grab one. All right. So let's begin. So today we're going to look at how well does our regression equation truly represent our data set. And one way to do that is by finding the correlation coefficient. Now we talked about correlation between two variables earlier. Okay, remember we related it to slope. We're going to kind of do the same thing, but this time we're going to find a correlation coefficient. Usually it's represented by the variable r. It indicates how well that equation actually represents our data set. Okay. Or it measures the strength of the relationship between those two variables. Now, I said r has a value, so that value is always going to be between and including -1 and +1. R will never be less than -1. R will never be greater than +1. If R is really close to 1 or close to -1, we're going to say that that equation is a good fit for that data set. If R is close to 0, then we're going to say that equation is not a good fit for that data set. So just like before when we looked at our scatter plots and we said, is there a positive correlation or a negative? We can do that same thing with the R value. So a positive correlation, all right, means that the two variables have a strong relationship or a strong positive correlation. This is when our R value is really close to 1, a positive one, right? If it's exactly 1, that means it's a perfect fit. All our data is lined up in a straight line. It is a positive value because, remember, like our slope, as x increases, y also increases. We can also look at a negative correlation. So that is when our R value is very close to -1. Then we will have a strong negative correlation between the two variables. Same idea here. If it's exactly equal to -1, that means it is a perfect fit. All our pieces of data is lined up in a straight line. Remember, it's negative when, as x increases, y decreases, just like it does for slope. When we looked at our scatter plots, there were some times when it was scattered all over. It wasn't close to a line at all. That would be no correlation between the data sets, okay? So if everything is too scrambled, all right, or if our R value is really close to 0, we say that there isn't a relationship between the two pieces of data. Now, how do we know how strong that relationship is? That's going to depend on our R value. So if R is, the absolute value of R is greater than 0.7, then we generally consider this to be a strong relationship. If our R value or absolute value of R value is less than 0.3, in general, we consider this a weak relationship. Okay. We're going to look at some scatter plots here. Okay, so notice that it's fairly close together, right? It's going in a positive direction, so this would be a positive correlation. As x increases, y also increases. Here, pretty close together. As x increases, y decreases, so that's our negative. Here it's kind of spread out, so there is no correlation. All right. Here we would have, if we were to draw a line, we have a positive slope. Here we'd have a negative slope. Here we would have no slope. All right, so when we're talking about correlation, I want you to think about the slope. Now, when we calculate this R value on the graphing calculator, you're also going to see this R squared. Usually people ask me what R squared is, so I wrote it down here, but we don't use it in this course. It represents the percent of data that is closest to the regression equation or the line of best fit. Okay, so that's just more for your information.